Hello everyone and welcome to this course. I am Ahmed Sawi and I am excited to have you here. If you have ever wanted to learn retrieval-augmented generation and build real AI applications instead of just learning theory, then you are in the right place. Throughout this course, we're going to build a complete RAG application from scratch using best practices and modern tools like LangChain, Gradio, UV, FastAPI and UV Core, and LLM providers such as OpenAI, Grok, Google Gemini, and ChromaDB. You'll learn what large language models are and how RAG solves many LLMs problems. We'll also break down every stage of the RAG pipeline so you know exactly what happens from the moment a user asks a question until the AI generates an answer. Then we will organize everything into a clean, scalable project structure that follows good software engineering practices. This makes your projects easier to maintain, expand, and deploy. After that, we will expose our RAG application through FastAPI, allowing it to become a real backend API that can be connected to web applications, mobile apps, or any front end. Also, we will explore one of the most important topics in AI engineering, choosing the right large language model. You will understand differences between open weight and closed models, compare popular LLMs, and discover how to choose the best model for a different RAG use cases. Throughout the course, we will write real code together, explain every concept in a simple language, and focus on practical implementation rather than unnecessary theory. By the end of this course, you will have a fully functional RAG application, a solid understanding of how modern AI retrieval systems work, and the confidence to build your own AI-powered projects. So if you're ready, let's get started and I'll see you in the first section. Hello everyone and welcome to this section. In this section, we'll explore the fundamentals of Retrieval-Augmented Generation, or RAG. So we're going to cover what is an LLM, and we're going to talk about tokens and context window. And also, we're going to explain what's RAG and the RAG's main pipelines, the document processing pipeline and question answering pipeline. By the end of this section, you'll understand the core concepts of RAG. So let's get started. So what is an LLM? LLM refer to large language model. An LLM is an AI model that is trained on a huge amount of text, such as blogs, websites, and articles. This allows it to understand and generate human language. Large refer to trained on a huge amount of text. So you can find ChatGPT act like a lawyer, a teacher, programmer, doctor, even an engineer, because he trained on a huge amount of text, so he knows a lot of things. Language refer to it works with human language. He can answer questions, writes text, translates, and more. And model is an AI system that learns language pattern to predict the next word instead of memorizing information like a database. Example of an LLM is GPT. The GPT model can answer questions, write text, and helps with coding. There's an important note. ChatGPT is an AI application that uses one or more LLMs under the hood. So you have to know that there is difference between GPT and OpenAI and ChatGPT. GPT is the model name. For example, GPT 4.1, GPT 5, or GPT 4.0. That's the model, that's the LLM. OpenAI is the company that created that model. And ChatGPT is an AI application. It can be website or mobile application. To learn RAG, you need to know many important concepts like tokens, context window, temperature, hallucination, prompt, and context injection. In this section, I'm going to cover the tokens and context window. Temperature and hallucination, we're going to cover them in the LLM section. And the prompt and context injection, we're going to cover it in the prompt engineering. So now let's start with tokens. A token is the basic unit of a text that an LLM processes. Instead of reading text word by word, LLMs break text into smaller pieces called tokens. This token can be a whole word, a part of word, a punctuation mark, a number, a special character. Let me give you an example. See this here? We got here a sentence called ChatGPT is amazing. We can convert this into tokens like that. Chat, the first token, GPT is amazing, and this mark here. LLMs measure context windows, input size, output size, and API pricing in tokens, not words. A context window is the maximum amount of information an LLM can consider at one time when generating a response. It includes your prompt, previous conversation, uploaded documents, and the model's generated output. Example: imagine an LLM has a 10 token context window, and you got this input. My favorite programming language is Python because it is simple and powerful. If this input exceeds the 10 token limit, the model keeps only the most recent tokens and forget the earlier ones. That's why the context window is important in RAG. If you send too much information, some of it won't fit, so the model won't be able to use it. What's RAG? Imagine that you want to create a customer service chatbot for a specific company. For example, a company called Caro Car Company or CCC. In this case, you will need to use a large language model. However, you will quickly run into a major problem. The LLM doesn't know anything about this company. He doesn't know the company's products, policies, or internal documents. It only knows what it learned during its training and what he is getting from internet results, which may be outdated or completely unrelated to the company business. For example, what is the refund policy of this company? In this case, the LLM can give incorrect answer to this question. So here comes RAG. So RAG stands for Retrieval-Augmented Generation. So it's an AI technique that retrieves relevant information for an external knowledge source and provides it to a language model so it can generate more accurate and context-aware answers. And this RAG has two parts: the retrieval, and that's mean find the right information, and the generation, and that's mean use that information to generate an answer. So instead of relying only on what the AI already knows, RAG lets AI look up information first before he give the user an answer. So with RAG you can create chatbots, customer services, and more. So RAG has two main pipelines. The first pipeline related to document processing, and we run this pipeline when you add or update any documents. And we got another pipeline, and it's question answering pipeline, and we run this pipeline every time the user asks a new question. So the first pipeline is the document processing pipeline. We got here some data, for example, PDF files, text files, markdown files, or any other file types that can contain data. First, we take those files and load them so we can use them in our program. After that, we split them into pieces, smaller pieces. Why we are doing this? We're going to talk about that in a separate lesson. Each step of those steps we're going to explain in details in a separate lesson. Okay? After splitting the documents into chunks, for example, we got a PDF with 100 pages. We're going to split this PDF, for example, let's say 400 chunks. After this, we convert those chunks to numbers, to vectors, and store them in a vector database. Those are the steps in the document processing pipelines. And as I have told you before, we're going to talk about each step of them in a separate lesson. So the second pipeline, and we execute this pipeline every time the user asks a question. We take that question and generate embedding. So we convert this user question to embeddings and search in our database to get the top chunks that can contain the answer of this question and build the prompt. This prompt will take the chunks that has the answer and the user question, and we send them both, the chunks and the user question, to the LLM, and the LLM get the answers from those chunks, those pieces of text, and return the answer to the user. We're going to talk about each of those steps in a separate lesson. Before I close this lesson, I would like to mention something. This section is theoretical section. We're going to talk a lot about RAG, about steps, about chunking, about the embedding, and how RAG is working. Because if you understand the theory, you can build a very good projects. Now let's get back to our two main pipelines. In previous lesson, we have talked about the two main pipelines. And inside the document processing pipeline, our first step is loading the documents. The documents can be PDF, Word, text, or any other file types. So we have those documents and we need to make our first step, loading those documents, so we can make a lot of processing to those documents to get the data from them and use those data inside our RAG project. So how to read those files? Let me show you the code. The code is going to be like this. Imagine that you have a PDF file and you want to read it in your RAG project. You can use this library, LangChain Community, or you can use any other libraries. Here is the LangChain way. You can easily just import PyPDF loader and just give it the path here. Here's the path of the file and the name of it. The name of it is Python book, for example. So if the file name was CCC terms and conditions, you should put the correct file name here. And finally, load this file using .load method. That's for PDF files. Imagine you got a text file. It's the same, but with a couple of changes. The first change is import text loader. You need a text loader, not PDF loader. And add here the path, and this path will be .txt. You can also use .md. And finally, just load it. So that was our first step, how to load the documents. Our first step in document processing pipeline. We are still in document processing pipeline. After loading the documents, it's time to split them into chunks, into smaller pieces. But why we do this step? Why we split those chunks into smaller pieces? We do that for a couple of reasons. The most important one is to get a better retrieval accuracy. If you embed an entire 100-page document as a single vector, a search query like any question, for example, how do I reset my password? Or another question, for example, what is the refund policy in your company? Has too much against the whole document. The embedding becomes too general, and this making it difficult to retrieve the exact section. By splitting the document into chunks, Each chunk represents a single topic or idea, allowing the retrieval to find the most relevant information. So that was the first reason. The second reason, the embedding models have token limits. So every embedding model has a maximum context length. For example, if the model limit is 8,000 tokens and your PDF has 50,000 tokens, you simply cannot embed the entire document in one request. So it must be divided into smaller chunks. The third reason is to reduce LLM input size, and this is saving the tokens and the cost. So even if you could retrieve the entire document and sending hundreds of pages to the LLM, this would cost much more and increase the latency and potentially exceed the LLM context window. So instead, RAG retrieves only the few relevant chunks, keeping prompts small and efficient. Now let's have a look at the code. After we load the documents from the loaders from previous lesson, if you remember, after we load them, we use recursive character text splitter from LangChain text splitter, and we provide here the chunk size, this chunk size by characters, and chunk overlap is 200. This chunk size refers to the size of the chunk. For example, if you got a PDF file, this file has, for example, 10,000 letters. With this chunk size 1000, you're going to get 10 parts. You can split it to 10 chunks because each chunk will be 1000. Okay, but when you add overlap and you have to add it, the game will change. Why? Let me explain what is this overlap. To explain overlap and how overlap is very important, let me give you this example. We got here this document. This document about Ahmed Sawi and his learning retrieval augmented generation. This document has 40 words. In this example, we're going to make the chunks by words, not by characters, to make it simpler. Okay, so we want to split this document into chunks, and we're going to split it into two pieces. Each piece has 20 words. Okay, now we got a problem. What if the user asks this question? Why is chunking important in LangChain? So in this case, the retrieval may not find any chunk that contains both LangChain and chunking together. So he can give the answer, incorrect answer, or he can say to the user, I don't know. So the overlap comes to solve this problem. This overlap usually meaning start the next chunk with last words from previous chunks. For example, instead of splitting and starting from chunking split large text and smaller, we can start the next chunk from this here, documents using LangChain, or from real documents using LangChain. Let me show you. Here is a chunking with overlap equals to 5. Now here's our first chunk. It will be the same. But if you have a look at the next chunk, you're going to see that it didn't start from chunking split large text. No, it started from here, from real documents using LangChain. So it started with the last 5 words here. So it didn't lose the context. So if the user asks why is chunking important in LangChain, the retrieval can find chunk 2 which contains both LangChain and chunking. So here LangChain and chunking. So the LLM has a better chance to get the correct answer. Now, after splitting the text into chunks, it's time to generate the embedding, to convert those chunks into vectors. So the embedding is our step 3 in the document processing pipeline. This embedding step comes after loading and splitting the documents. Embeddings usually means a numerical representation of a piece of text that captures its meaning, not just the word it contains. So it represents the text and its meaning, not only the text, okay? For example, we got here a chunk called Ahmad Sawi is learning retrieval augmented generation using LangChain. When you embed it using an embedding model, the result should be something like this, a number representation. So we convert it into a vector, and the actual vectors usually contain hundreds or thousands of numbers. For example, those number dimensions here, depending on the embedding model. So we got many embedding models like the text embedding from OpenAI and the BAAI embedding model and Gina embedding and other embedding models. To do the embedding in code, you're going to do something like this. You're going to import the Google embedding or OpenAI embedding or any embedding library that you want to use their models and add here the model name. For example, this model here, Gemini embedding 001, and just add the key to access this model. So the code's going to be something like this. If you are too excited and want to do the code, please don't do it right now. Just wait until we are done with this theoretical section, and we're going to code with each other in the coding sections. Most of this course is going to be coding. After convert text into vectors, the RAG pipeline continue like this. Store in a vector database. Let's store those chunks and their embeddings in a vector database. So text is converted into vectors. The vectors are stored in a vector database. We don't store only the vectors, we store the vectors with the original texts. We save them in a vector database such those databases: Chroma, Pinecoin, Quadrant, Weave8, Melvus. Those are vector databases. In this course, we're going to use Chroma. And as I have told you, we save the text with the vector. So we're going to save something like this. LangChain helps build RAG applications and the vector of it, the numerical representation. And the actual vectors usually contain 100 or 1000 of numbers, depending on the embedding model. How to do this step in code? To do this in code, as I have told you, I will use Chroma database. So you're going to just import Chroma from LangChain Chroma and create a variable called vector store, and you're going to store the documents. The documents is going to be chunks. The embedding, we're going to add here the embeddings that we have created from the embedding model, and here the directory that you want to put your database in. You can change this directory path. Now we are done with our first pipeline, the document processing pipeline. Now we got documents, we load those documents, we split those documents into chunks, we generate embeddings from those chunks and store them in a vector database. Now we are done with our first pipeline, and it's time to go and explain the second pipeline, the question answering pipeline. Now we are done with our first pipeline, the document processing pipeline. And let's go to the second pipeline, the question answering pipeline. We run this every time the user asks a question. Here is the document processing pipeline. We have already explained it. The second pipeline is the question answering pipeline. The user defined a question to our RAG app. We get this question and create embedding, and that means we convert the question into a vector. Then we search in our vector database, for example, Chroma database, to get the best chunks that can answer this question. Then we got those chunks from our database and send those chunks with our question to the LLM. So we built a prompt to send it to the LLM, and the LLM now has the chunk that contains the answer and also has the question. So he returned to us our answer. and we return this answer to the user. So our step 1 is define the question. No need to explain this step, it's very easy step. Just a user ask a question. In step 2, we convert this question into an embedding. Just like the document, the user question is converted into a vector embedding using the same embedding model. Why? Because the vector database compares vectors, not raw text. So we take the question and we pass it to an embedding model to create a question vector. Now, after generate question embedding, we search in our vector database to get the most relevant chunks. We got those chunks to send them to the LLM. So this is our step 3. Search the vector database and retrieve similar chunks. So the question vector is sent to the vector database, and the database compares it with all stored document vectors and finds the most semantically similar chunks. Notice that it is not searching for the same words, it searches for similar meaning. For example, if the question is, how can I get my money back? The database may retrieve a chunk containing customers can request a refund within 30 days. Even though the words are different, but the meanings are similar. How to do this step in code? To do it, you're going to type a code like this. You're going to create the retriever, and this retriever has to search your vector database. You add those two properties. The first property, search type, similarity. This is to tell him to use vector similarity search. It compares the embedding of the user's question with the embeddings stored in the vector database. Okay, that's the similarity searching. And here the other property called search quarks. K is going to be 3. That's mean return the top 3 most similar chunks. If you change this number and make it 4, he's going to return the top 4 most similar chunks. At this point, nothing has been searched yet. So we need to perform the search. So we add this new variable here. Documents is going to be retriever dot invoke the question and just pass the question. So you pass here the user question to allow this retriever to return the document objects of those chunks. Now let's go to step 4. After retrieving the top chunks, we're going to build our prompt. We're going to combine the user question with those chunks and instructions to send them to the LLM. So, after retrieving the most relevant documents, we don't send them directly to the LLM. Instead, we build a prompt that contains the user question, the retrieved context, the instructions telling the LLM how to use that context. So the prompt is going to be something like this. You are a helpful AI assistant and add here some instructions. Then add the context. Those are the most 3 relevant chunks that we have retrieved from our database. We send it to the LLM as a text, not vectors. Okay, so this is the chunk 1, chunk 2, chunk 3. We send them as text. And now we send it the question. You can ask him any question. For example, let's say, what is the privacy policy of the car company? And here we send with this prompt those chunks related to privacy policy. To make this in code, you're going to type a code like that. Look, I'm not going to explain this code right now. We're going to explain it in our coding sections. So I don't want to waste your time and waste my time, because I will explain this code in details later when we build the prompt using the coding. But the code is going to be something like this. After building the prompt, it's time to send it to the LLM to generate an answer. So this is our step 5 and our last step. The LLM is going to generate the answer. So the LLM reads our prompt. It reads the instructions, the retrieved context, those refer to chunks, the chunks that contains the data. Those data, the LLM can use them to get the correct answer. And also read the user question. Then the LLM generates the final answer. To do that in code, you're going to type something like this. You can use chat grok, and it's free, but got a limit. You just need to add here the model, for example, OpenAI, GPT, OOS, and add here the grok API key. You can also use a paid LLM using this chat OpenAI and also add the key. This key is a secret string. You get it from OpenAI platform or grok platform. And finally, you just invoke the prompt that you have created to return a response answer. So now those were our steps. The user has a question, generate embedding for that question, doing some searching to get the top relevant chunks that may contain the answers, then build the prompt using that question and those pieces of data called chunks, send them to the LLM return to us the answer. Hello everyone and welcome to this section. Before we start building our RAG application, we need to prepare our development environment. We will install Python and use UV to install the packages we will use throughout the course. We're going to set up our Python environment and we're going to compare UV and pipe or pep, and I'm going to tell you why it's faster than pep. By the end of this section, you will have a complete Python development environment ready to build and run your RAG application. So let's get started. In this section, we're going to set up our Python environment using UV. We need to install Python because the entire RAG application will build with it. Without Python installed, we wouldn't be able to write, run, or test our RAG application, or use the AI libraries it depends on. We're going to use UV. UV is a fast, modern Python package and project manager written in Rust. It lets you create virtual environments, install packages, and manage dependencies much faster than traditional tools like pipe. So, why UV is faster than pipe? UV is written in Rust, which is significantly faster than Python for many tasks. And also, it has parallel downloads and installations, so it installs multiple packages at the same time. It has also optimized dependency resolution, making it quicker to figure out compatible package versions. And finally, it has global package cache, so packages you have already downloaded are reused instead of being downloaded again. Now, let me show you how to install packages using UV. It's pretty simple. You just need to type UV add and the package name. For example, UV add FastAPI. This is the package to create our API. If you want to remove a package or delete a package, you're going to type this command, UV remove the package name. For example, UV remove FastAPI. If you want to install all packages or clone the project or sync the project, you're going to type this command, UV sync. And this command will install all the libraries inside a file called pyproject.toml. So if this file pyproject.toml has a list of dependencies and you run UV sync, he will install all those libraries. And you're going to need this command when you want to clone a project that already exists. And in this course, we're going to run those commands and you will be familiar with them. In this lesson, we're going to learn how to install UV in Mac. So in Mac, just open a terminal like that and just type this command pro install UV and press enter and wait until the installation is done. Now we have successfully installed UV. To double check, just run this command uv version and press enter. Now you should see something like this, UV and the version number, like this. Now after installing UV, let's create our RAG project. So let's create here a folder and name it RAG chatbot. Okay, and let's open VS Code. Here's our code editor, VS Code, and drag and drop our folder inside it. Okay, now let's run our command to create the project. So just type uv init and press enter to create our project. Now, if you have a look here, this command creates for us a couple of files. They get ignored. In this file, we put here sensitive files or unnecessary big files, and so. And here, by project.toml, here's the file that I have talked about in first lesson. When you install a library, it will appear here. Let me show you how to install a library. So let's open the terminal from the down here and just type uv add, for example, let's add FastAPI and press enter. Now look, we have successfully installed FastAPI library. If you want to remove it, just type uv remove FastAPI, the name of the library. Look, when we run this command, now the list is empty because we have removed this library. And here in main.py, you can type anything here. Now, to run this file, just type this command. Let's clear. And just type this command, uv run main.py. It's the name file. When you press on it, you're going to see this. Hello from RAG chatbot. Here's the print here. You can type here your name. For example, hello Ahmed. And let's run our command again, uv run main.py. And we got here, hello Ahmed. Hello everyone and welcome to this section. Now it's time to start writing code. In this section, we'll build the document loader pipeline, which is responsible. We will build the document loader pipeline, which is responsible for loading documents, processing them, and preparing them for retrieval. So we're going to cover how to read files, MD, PDF, text, docs files, how to split documents into chunks in code, and how to get the LLM API keys from OpenAI platform and from Google AI Studio and also from Grok, the free ones and paid ones. You're going to learn how to create embedding in code, and also we're going to cover Chroma database. By the end of this section, you will build a document loader pipeline that ingests, processes, and prepares documents for retrieval in code. In this lesson, we're going to learn how to implement our first step in RAG. And this step is loading the documents. We want to use documents like text files, PDF files, Markdown, etc. We want to load those documents so we can use them inside our RAG pipeline. So we can give those files to our RAG pipeline. How to do this in coding? It's very simple. First, we need to install this library. So open the terminal. You can open it from drag and drop here like this, or you can use this shortcut, Control and this sign here, okay, to open it on Mac. And you can also know the command from Windows if you just hover here on the terminal. Okay, now let's open this pyproject.toml And let's have a look here at this dependencies. And in terminal, let's just type this command, uv add. We use uv add to install a new library. And after uv add, just type the library name. The library name is LangChain Community. So LangChain dash community, and press enter. Now look, we now installing the library. And if you have a look here, the dependencies list were empty, but now we got a library inside it called LangChain Community. Now let's go to main.py and do some imports from this library. So let's remove all of that code, and from LangChain community dot document loaders import text loader. Okay, and let's add here inside the files a test file. So let's create a new folder and name it data. We're going to put our data inside this folder, and let's just add a test file.txt. So test.txt, and let's just type here anything, for example, hello rag. And let's try to load this file so we can later give it to LangChain to split it into chunks and get the top chunks. So here it's pretty easy. Just define a variable called loader, and this is going to be text loader, and just put the path of this file. The path is data folder slash test.txt, like that. Now let's press save and let's load the documents. So docs is going to be loader.load. And finally, let's try to log those docs. So print docs. Now let's run this file. So in terminal, just run uv run main.py and press enter. Now look, we got here an array. The type of it is document. The source is data folder test.txt file. And the page content is hello rag. Let's try to type anything here. For example, AI is powerful tool. And let's try to run our app again. So uv run main.py. And we got here hello rag, AI is powerful tool. That was a txt file. What if we want to add an MD file, not text file? So let's try to create an MD file. So in data here, let's add a test.md, and let's type here anything. Hello from MD file type. And inside main, instead of just importing the test.txt, we're going just add test.md, like that, and press save. And now let's run our file. Now look what we got in the log document. The source is data test.md, and the page content is hello from MD file. I got here a PDF file, and it called test.pdf, and just contain hello from PDF. And also have this file, Word file, and just inside it hello from Word file. I have just generated them from Google Docs. So here you can type anything and press here file, download, and you can download it as PDF, as plain text, as Markdown, or as Microsoft Word. Okay, I will just import those two files inside our data to show you how to read those two types of files, the docs file and PDF file. Let's start with the PDF. So first, let's comment those two lines of code here, and up here from LangChain document loaders import text loader, we will import another loader, and it calls by PDF loader. Okay, and here we're going to define the loader, and is going to be py PDF loader, and inside it just add your PDF path, and it is inside the data, and it called test.pdf. So here test.pdf, and let's just load it. So loader.load and press save. And now let's try to run our file. So here let's just type uv run main.py. You are going to see this error: py-bdf package not found. Please install it with pipe install py-bdf. So we need to install this library, but we're going to install it using uv, not pipe. So uv add py-bdf, and let's run our app again. So uv run main.py. Now look, we got here the data of the PDF. The source is data test.pdf, the total pages is 1, and the page content is hello from PDF file. But why we have installed this library by PDF? We have just installed this library by PDF because our py-bdf loader doesn't actually parse PDF files itself. It's just a wrapper around a PDF parsing library. So this py-bdf loader internally uses this library, py-bdf. Okay, so we need to install this to use this. Now you can read text files, MD files, and PDF files. In this lesson, we're going to learn how to read Word files. So let's comment those two lines and try to read this file, test.docs. So here from LangChain, we're going to add a third import. And this import is going to be docs to text loader, this import here. And as we have done before, loader is going to be docs to text loader, and just give it the path. The path is going to be data slash test.docs. This line here is like the line here, text loader and py-bdf loader. What does this line do? This loader line here, the first line of each step you load a document, here we are creating an object. Think of it like telling LangChain, this is the Word file I want to work with. So think of that you are telling LangChain, here is the Word file I want to work with. And second, we're going to tell LangChain to read it. So docs is going to be loader, this loader.load. That's mean just read it. Okay, now let's press save and try to run this file. So uv run main.py. And look, we got a similar error that we have faced before when we trying to load the PDF. And this error called module not found error. No module named docs to txt. And what we need to do is just install this library. We need to install it because docs to text loader depends on this library, docs to text, to extract text from docs files. So what we need to do is just uv add this library here and press enter to install this library. And after that, we can run our app again. So uv run main.py. And look, we got here the data here, document test.docs, The page content is hello from Word file. Now it's time to feed our RAG system with real data. This test data were just for testing, so let's delete them, move to trash, and get some data. I have here a data with a fake company called Car Caro Company, or 3Cs. It's just a fake data, fake dummy data for testing. It's a company for selling cars. We got here some data about cars, about company, about contact support, financing, jobs, offers, and salaries, and so. So we're going to build this RAG to answer question depend on this data. So our first step, if you remember, was to load the data, load the document. So if you see here, that was for Word files, and we want to use this txt files. So let's remove that and also remove the PDF and remove those imports. We got here only text loader, and let's have a look here. We got here the text loader, but it was for only single text. We want to use multiple text files. So how to do that? That's pretty simple. We're going to import something called directory loader. Okay? And instead of using this text loader, we're going to just use directory loader. And inside it, we're going to pass first the data folder. That's this folder here, the data, and add a global pattern to tell our loader to use all the files inside this folder. So to do that, we're going to define globe. It's going to be 2*/ dot txt. As simple as that. And loader cls. This is to tell the loader to use text loader. Use this text loader to read this text files, because those files may be PDFs, maybe words, or something else. So we choose text loader for text files. And we got here a prop if you want to show progress bar when files are loading. Because we are loading multiple files, I prefer to show the loader. So show progress, I'm going to set it to true. Okay. And here we got here docs, let's name it and make it documents. And let's print them. Now let's try to run our app. So uv run main.py. Oops, we got here an error. Import error. To log the progress of directory loader, you need to install tqdm. I don't want to install a lot of libraries, so let's remove this line here. Show progress, let's just remove it. And now let's try to rerun our app again. uv run main.py. And great, we got here our files, and our system can read our files perfectly. So now we are done with our first step in RAG, and this step was reading the files. If you remember here, we are done with this step, loading the documents. Next step is split those documents to chunks, to pieces, before we generate the embedding, and that's what we're going to learn next. Now let's learn how to do step 2, split documents into chunks. How to do that in RAG. To do this using LangChain, we need to install a new library. And this library called LangChain Text Splitters. So in the terminal, just install this library, uv add LangChain Text Splitters, and press enter. Now after installing the library, let's import it. So from LangChain Text Splitter, just import recursive character text splitter. And down here, let's remove this print statement and let's define a variable, name it text splitter. And this is going to be recursive character text splitter. And we need to provide two params to this class. The first param is chunk size. And this chunk size refers to number of characters. So let's try to make it 1000. And also add here the overlap. So chunk overlap. And let's add overlap with 200. And this overlap, as I have told you before, to tell LangChain to repeat the last 200 character of chunk at the beginning of the next chunk. Okay? Now let's take those documents and split them into chunks. So let's create chunks variable, chunks, and this is going to be text splitter dot split documents, and just pass those documents here to split them into chunks. And let me show you the chunks. Let's run our app. So uv run main.py. Now those are the chunks. Let's try to get our first chunk only. So index of 0 and clear. And let's run our first chunk. This is our first chunk, 1000 characters of it. Let's try to decrease the number of characters. So let's make it, for example, 25 characters, and the overlap is 10. And let's clear and rerun our app again. Now look, we got here a small chunk with 25 characters only. So here, if you count the characters here, it will be 25 characters, including spaces, of course. So let's return it to 1000 and the overlap is 200. Now you are done with step 2, split documents into chunks. Let's go and create the embedding. But first, let's just add some comments here. So let's add some comments here to make things better for you. That's step 1. Load the documents. And let's take a copy of it and paste it here and add here step 2. Split documents into chunks. And the next step, step 3, we're going to create embeddings. In this lesson, we're going to learn how to get the free and paid API keys. We're going to use those API keys to make a connection with our app and the LLMs. So first, let's start with the free keys. So in Google, just search for Grok console and open this link here, console.grok, and create a new account. Let's continue with Google. Now we are here in Grok. How to create an API key? Just press here at the top here, press on API keys, and press here, create API key. Here's the name of the key. Let's just type any name, for example, chatbot, and I'm going to make it no expiration. Now, after verification, let's press submit to create our API key. Now, copy this key, copy it, because you will not show it again. So copy it and go to the project. And let's create a new file and name it .env. So our first key is going to be Grok API key. And this key is going to be equal this value. And never share this key with anyone. In general, in programming, anything called key, whatever, it's a string like this or a file, Never share it with anyone. Think of it, it's like the key of your house or key of your car. Do you share those keys with anyone? Of course not. So in programming, anything called key, never share it with anyone. Now that was Grok API key. We're going to use a bunch of free models of free LLMs that we're going to use in our chatbot app. Now let's go and create our Google API key. So in Google again, just search for AI Studio Google API key and open the Google AI Studio and press here Get Started, and see at the down at the left here, press on this Get API key. So go to the top here and press Create API key. And here you can select the name. I'm going to name it Chatbot. And you need here to create a project. So let's create it quickly. Press here Create Project. Let's name it Chatbot and press Create Project. Failed create. Try again. Let's try again to create this project. It fails again. Why? Let's refresh the page and press Create API key. It's not my fault, it's Google fault. Let's press here Create Project. Let's name it Chatbot and press Create Project. I got here failed to create project. The project creation failed. Please try again. It's a Google fault. It's not my fault. I don't know why it failed to create a project, but you probably will not face this error. So I have another account here. Just open it and press here on Create API key and press your Create key. And then you're going to find this key here, this API key here, and press here to copy it, or press here also to copy the key. Okay, and close it and go to our project, and let's create another variable and name it Google API key, and this is going to be this value. Now we got here Grok API key and Google API key. Now it's time to get our OpenAI API key. Now let me show you how to get the API key from OpenAI, but you have to make sure it's not free, it's a paid key. So let's log in our OpenAI platform. It's called platformopenai.com. As I have told you, you have to add credit at least $5 to use those OpenAI models, okay? And press here on API keys and press here create new secret key at the top right here. Since I have already two keys, I will copy one of them and paste it inside my .env file. Now let's create a new variable and name it OpenAI API key, and it's going to be this key. Now after creating those keys and put them inside .env file, don't forget to go to getignore and press here to getignore file and add here .env file. So we don't want the get system to track this file because this file contains sensitive data and we don't want to push it to the GitHub. So to ignore this file, to let the Git knows that don't see this file and don't track it, just put it inside this getignore file. Okay? In this lesson, we're going to learn our third step, create the embedding. There are multiple models that can create the embedding, and we're going to use two, one paid and one free, and the two of them are powerful. So let's start with the free model. So to use our free model, we need to install this library, uv add langchain Google Geni. Now let's import it. So from langchain Google Geni, import Google generative AI embeddings, and let's copy it, and down here let's define our embedding variable. So embeddings, and inside it, we're going to pass two things. The first is the model, and we can get the model name from the internet. So let's search for Google embedding models. You can open this page. You can pick this model name here. Here's some docs. You can also pick this model here, Gemini embedding 1. And also we got here Gemini embedding 2. I'm going to use this, Gemini embedding 2, and just paste it here. And the second thing is the Google API key. So Google API key, and we need to get it from .env file. Here, from this file here. So to get data from .env, we need first to import OS, and from .env import load.env. And down here, we need to read our .env file. So let's call this function here. Now let's scroll down, and here inside the key, we're going to use os.getEnv, and inside it, we're going to just pass the environment variable name. So let's go here to .env file and copy this name here. This name must be the same as here. Okay. And now let's try to test our embedding. So let's remove this print here, and down here, let's add a print. And inside it, we're going to add embedding dot embed query. And let's inside it, we can pass anything we want to embed. For example, let's embed hi. For example, let's run our app. So uv run main.py to see how the embedding model will convert hi text to a vector. Look, that's the embedding for hi. Let's try to make an embed for a chunk of our chunks. So let's add here chunks. Let's get the first chunk dot page content, and let's rerun our app again. So uv run main.py. Look, we got here a vector of numbers. Now that was the embedding process, and it's our third step in the document processing pipeline. Our last step is storing the chunks with their embedding in our vector database, and we're going to use our Chroma database. But before I close this lesson, you can use another model for embedding, and we can also use our OpenAI embedding. But how to use it? That's pretty simple. First, we need to install this library. uv add langchain OpenAI. And after installation, let's just import from langchain OpenAI, just import OpenAI embeddings. And down here, see this part of code? We can just comment it and just type embeddings is going to be OpenAI embedding, and inside it, we're going to just pass the same two things, the key and the model. The model, you can search also in internet. OpenAI has two main popular models for embedding, so we can just OpenAI embeddings models in Google. Look, OpenAI offers two primary third generation text embedding models, text embedding 3 small and text embedding 3 large. You can open this page and can see those two models name here. So let's copy this model name and let's pass it here. And also don't forget the key. So API key is going to be, we're going to get it from our .env file. So os.getenv, and inside .env file, open API key and just paste it here. Now let's try to run our app and see. Look, we got here a different number because we have used a different embedding model, and it was the embedding from OpenAI. Let's comment it and return to the free model from Google. Okay, now we are using the free model from Google. And see you in our last step. Store the chunks embeddings in our vector database, Chroma database. Now let's implement our last step in document processing pipeline and storing the chunks with their embedding in a vector database, and we're going to use Chroma database. So now let's go back to our VS Code. Let's copy those two comments here and paste them here and add step 4, and let's name it store embeddings in Chroma. Okay. To use Chroma database, we need to install this library. So in terminal, just type uv add langchain Chroma and press enter to install this library. Now, after installation done, let's just import it. So from langchain Chroma, import Chroma. And down here in step 4, we're going to define our instance. So I'm going to name it vector store, and he's going to be Chroma dot from documents. The documents is going to be the chunks. Okay. And the embedding property is going to be this embedding from Google embedding. And finally, the persist directory. And here's the directory. I want to store our Chroma database inside this data folder. So let's add this path, data slash, let's give another folder name. Let's name it ChromaDB, like that. So here we tell Chroma to save the vector database inside this path, inside this data folder, and it will create another folder inside it called ChromaDB. And here we tell her to use this embedding model from Google. And we can also use this from OpenAI. If you comment this and uncomment this, you're going to use the OpenAI embedding model. And here we tell Chroma those chunks, those are the data that we want to store inside it. Okay, now let's have a look at our vector database. So print vector store, and let's run our app. So uv run main.py. Now we have created our embedding and store them inside our vector store. And if you open the folders here and go to data, you're going to see this new folder, ChromaDB. And here we store our data. We store the data as text and as vectors and also as metadata. Metadata like file name, page number, the file resource path, and so on. And now you have done with our last step in document processing pipeline. And it's time to go to our user question pipeline, when user asks a question and get an answer. Hello everyone and welcome to this section, question answering pipeline. It's the second pipeline in RAG. you're going to learn inside it how to create the question embedding and retrieve the best chunks and build the prompt and generate the answer to return it to the user. By the end of this section, you will build a complete question answering pipeline that retrieves relevant information and generates accurate responses. Now, let's start with our first step in the user question pipeline. And the first step is the user question. User asks a question, so we need to input it here. So here in the code, let's add here a comment for second pipeline. So let's add here something like this. Later, we're going to separate all of that code into separate files to make our code base cleaner. Okay, now let's add a comment here. Second pipeline, and it is retrieval augmented generation. Like that. And let's add our first step. Let's copy this comments here and paste them here and make this step as 1. And the first step is define the question. This step here, the user question, to define the question. Okay, now we can make this question a variable like this for testing. For example, the question is, what is CCC or triple C? Or we can make the question a user input. So input, and let's add a message for the input. And the message is, enter your question. And let's just print this question for now. So print the question. Now let's save and let's remove this print here and this print here also. And just let's print the question. So in the terminal, just type uv run main.py. Oops, uv run main.py. Now we got here, enter your question. My question is, what is CCC? And press enter, and he logged it. What is CCC? In this lesson, we're going to implement those 2 steps. Create the embedding for the question and retrieve similar chunks, because we're going to do this in just 1 step. Okay? So here, let's copy this comment here and paste it here and make this step 2 and 3. And the title of it is create an embedding for question and retrieve relevant chunks. Okay, so we're going to create a variable and name it retriever. And this is going to be our vector store dot as retriever. And we're going to pass 2 things. First, the search type, and is going to be similarity. And search quarks. And inside it, I'm going to pass the key. This key refers to number of chunks that we want to retrieve, the most 3 relevant chunks. This retriever is something like, imagine you have a big library of text chunks stored in Chroma, in our database, vector database. A retriever is like a librarian. You can ask a question and it finds the most useful pages or most useful box. This search type means find the chunks that mean something similar to my question. And this search quark means only give the top 3 best matches. This small key refers to the number of chunks. It's like how many chunks to return. Okay? Now let's retrieve our first top 3 chunks. So here, let's add another variable, retrieved docs, and it's going to be retriever.invoke, and just add the question. This question that the user will enter. Okay, now let's try to print the retrieved docs to see our docs, our top docs. So in terminal here, let's run our app and let's ask a question. The question is going to be, what is CCC? And press enter. Now look, we got here 3 chunks. It's an array of 3 documents. Here's the first document, and here's the second document, and here's the third document, because we provide here the key of 3. Let's retrieve our first doc. So the index of 0.page content, and let's try to retrieve our first document text. So you will run main.py to run our app, and let's add our question. The question is, what is CCC? And we got here the first chunk. What does CCC or 3C stands for? Here are the chunks. This chunk will send later to LLM. We will send it with another 2 chunks to the LLM to allow the LLM get the answer from it and return it to the user. If you remember, I have told you those 2 lines of code do those 2 steps. Create the embedding for the question and retrieve the relevant chunks. So now we are done with those 2 steps. The create embedding for the question and retrieve similar chunks. So this step is done, and this step is done, and this step is done also. And it's time to build the prompt and send our prompt to LLM. Now it's building the prompt step. So let's go back to the code. Let's copy this comment here. And it will be step number 4. And this step is going to be build or create the prompt. It's the prompt that we're going to send to the LLM. Let's remove this print here, and let's join those 3 retrieved docs. If you remember, in previous lesson, the chunks were 3 chunks, the most relevant 3 chunks. We want to make those 3 chunks, get the content from them, and make them only 1 string to send to the LLM. How to do that? We're going to create a variable here called context, and we're going to add 2 slashes in to add 2 new lines, dot join, and inside the join we're going to add documents dot page content for document and retrieved docs. This will be our context. What does this line of code means? As I have told you before, we got 3 chunks here, and we got in those 3 chunks, we got 3 separate texts inside those chunks. We want to merge them in only 1 big string of text. So this line, it takes the page content. It's document, not document. Sorry for this mistake. It's document, okay? It take the page content, and this page content mean the string text of this chunk. It take this text and glue those text together with a blank line, those 2 /n, to create 2 lines between them. Okay, here's an example. Let me show you an example. Look at this example here. We got here 3 docs, three chunks. The page content of the first one is Python, a programming language. The second, it was created by Gradio van Rossum. The third is it's widely used for AI. The output, if you put this inside this join, the output is going to be like this. Okay, so that's it. That's what this line of code are doing here. Okay, after we have created the context, let's create the prompt. So the prompt is going to be chat. We need to import chat prompt template. So up here, did we have installed the LangChain core? We didn't install it. So let's install this library. So in the terminal, just clear and just type uv add LangChain core and press enter. Now after installation, let's go to main.py and let's import from LangChain core.prompts, just import chat prompt template. And let's copy it and go down here. The prompt is going to be chat prompt template dot from template and just pass this string. Let's create a quick prompt and later we're going to enhance it. So the prompt is going to be you are an AI assistant. If you don't know the answer in the context, say I don't know. And let's add the context. And we're going to pass the context. This context here. And question is going to be the question. This user question here. That's the user we're going to input. And finally, let's return the answer. And that's the prompt template. This prompt template is like a fill in the blank message for the AI. Context and question are empty slots. We will fill it later. This context, we're going to pass this context from relevant chunks and the question from the user input. And this prompt, it's not the best prompt for now, but I move with you step by step. Later, we're going to enhance this prompt. So now that was the prompt template. So let's add here template like that. And let's create another variable and name it formatted prompt or final prompt. This is the prompt that we're going to send to the LLM. It will going to be prompt template dot format, and inside it we're going to add the context is going to be this context here, and the question we will pass the user question here, that question. Let's remove this print and let's take this question and pass it here like that. Now let's ask a question and try to print this formatted prompt. So let's print formatted prompt and pass here formatted prompt. And now let's ask a question. So uv run main.py. And let's ask a question. The question is going to be, what is Carol? And press enter. Now look, we got here. Here's the prompt that we're going to send to the LLM. Look, the prompt is saying you are an AI assistant. If you don't know the answer in the context, say I don't know. Context, this is the context of relevant chunks. Those are the chunks that we have got from our Chroma database and send them to LLM to get the answer. Okay, and now we are done with the build prompt step. And it's time to send our message to LLM to get the answer. Now, finally, let's send our question to the LLM to get the answer. So, here, step number 5. This step is going to be generate the answer. I'm going to use two LLMs. One is free and one is the paid OpenAI. So LLM is going to be, let's have a look at project.toml. We don't have here the Grok library. So let's install a new library. UV add lang chain Grok. Grok with Q, not K. Don't type Grok. No, it's Grok with Q. And press enter to install this library. So here in main.py, let's go up and import from LangChain Grok with Q, import chat Grok. And at the down here, the LLM is going to be chat Grok. And we need to pass two main things. The first thing is the model name, and I'm going to use Quen. So you have to put the exact model name. I'm going to use Quen slash Quen 332p. And the second thing you need to pass is the API key. And this key, you can get it from .env. So open .env. And since we are using Grok, let's get this Grok API key. You have learned how to generate those API keys before, if you remember. Just go to Grok dashboard and create a new one. It's free. And the API key is going to be os.getInv and just pass here the Grok API key. And finally, let's get the answer of the question. So response is going to be llm.invoke the formatted prompt. Response, like that. And let's print the answer. So print answer as and return here response.content, like that. Let's remove this print and leave only this print statement. This will return our answer. So let's clear the terminal and just run our app. UV run main.py. Now we got a question. What is CCC? The answer is, okay, the user is asking what's CC. Let me check, provide. Here's the thinking process. And here's the answer. The answer is CCC stands for Car Company. It's fictional test data created for learning and RAG. Oops. And that's the answer. Let's ask another question. So let's run our app again. Oops, we got here an error. Code 429. You exceeded current quote. That's this error from Google Gemini. Let's go and replace it with GPT. So here, go up here. And instead of using this embedding model, I'm going to use the OpenAI model. So let's comment that and uncomment that. We're going to use text embedding 3 small. Now let's press save and let's delete ChromaDB. Let's remove this folder and start the embedding process again. So let's clear and rerun our app again. And the question is, who is the CEO of CCC? And press enter and see. He is thinking, okay, let's see, the user is asking about, here's the thinking process. And the answer is, I don't know. Let me check if we got the CEO. we got here the CEO and it called Marcus Caro. Here is the grandson of the founder. So this answer was not the best answer. Let's try to use our GPT model. So let's comment those 4 lines and create another LLM variable here, and it's going to be chat OpenAI. Let's import it first from LangChain OpenAI, chat OpenAI. So let's import it and use it down here. Chat OpenAI. And as before, we need to pass the model and API key. The model, you have to make sure you get the correct model name. You can get it from the internet. GPT 4o mini. That's the model name. And the API key is going to be os.get env, and inside it we're going to pass here the environment variable name. So here, just pick this name here, OpenAI API key, and paste it here. Now let's try this model and ask the same question. So UV run main to run our app, and let's ask the question: who is the CEO of the company? We got here the answer. The CEO of the company is Marcus Caro. Let's ask him another question. Who is the founder of company? The founder of Caro Car Company is Eleanor Caro. Let's check this Eleanor Caro. Okay, we got here in the data. Eleanor Caro opens the first Caro Car showroom, and that's it. So you can also change the model here. For example, you can use GPT 5.5, and let's ask a question. Let's type in the question. Let's ask anything about the history. Let's tell our RAG app this question. Tell me about CCC history. And press enter to see. Now here's the history of our company. And now you've learned how to connect the large language model to get the final answer in RAG. But so our user question pipeline has been ended, but our journey is not ended yet. You still need to know a lot of things about RAG. Hello everyone and welcome to this section. As our project grows, keeping the code organized becomes increasingly important. In this section, we will restructure our project into a clean and scalable folder structure that's easier to maintain and extend. We will also move configuration into the right place and remove hard-coded values. By the end of this section, you will organize your RAG project into a clean, scalable, and maintainable folder structure. So far, we have been putting everything inside the main.py file, this file. That was fine while we were learning the basics, but it's not a good approach for a real project. As your application grows, keep all the code in a single file makes it difficult to read and maintain and debug. Instead, we will organize our code into multiple folders and files, making the project clean, well-structured, scalable, and easier to maintain. So let's create a couple of folders here. So here, let's close this data and create a new folder. and name it src. Inside it, we're going to create another folder. I'm going to name it API. This folder will be responsible for the API logic. And another folder called core. We will put here the configurations and settings. Another folder, I'm going to name it LLMs. Inside it, I'm going to put the logic that's related to LLMs. And another folder called ingestion. Here we will put the embedding process and loading the documents. And another folder, I'm going to name it prompts to put the prompts inside it. And also don't forget the retrieval retriever folder. This will be our folder structure. And in the future, if we need to add more folders, we're going to create them. Now let's move our code into separate files. The first here, for loading the document. This code is responsible for loading the text data from here. So we're going to create inside ingestion folder, we're going to create a new file and name it ingest.py. And inside it, we're going to copy those code here and paste it here. Let's remove this comment and let's import the directory loader and text loader. This import here. So let's cut it and move it here like that. Now we need this document. So easily go here and let's just import it. So from src dot ingestion, because we got here the folder named ingestion dot ingest, the file name, just import the documents. These documents here. Now let's press save and let's try our app. So uv run main.py to check, to make sure that everything is working perfectly. The question is, let's ask a question. For example, what is the best car? Great, we got here an answer. I don't know, the context doesn't name one overall list car are best for different needs. And here are 3 cars. Spark, best for urban drivers. And so that's the answer. Okay, so our app is working. Let's move this step to split documents into chunks. So inside ingest folder, we're going to create a new file and name it splitter.py. And inside it, I'm going to just copy that all code here and paste it here. We need to import recursive character text splitter. So let's copy this import and paste it here and import the documents from the ingest folder. So from src.ingestion.ingest, just import the documents variable like that. And now let's go back to main.py and remove this import here. And now let's just import those chunks. So in main.py from src.ingestion.splitter, just import the chunks. And no need for this import. Here, we just select src.ingestion.splitter because it's the path to it. If you have a look here, src.ingest.splitter. We got here the chunks. So we import the chunks from it. Now let's press save and let's try our app. Let's add here some data. For example, inside the car, let's add here some text. Let's just type here, the best car is Sawi car, and it costs $1 million. Now let's try our app and let's ask this question. What's the best car? What is the best car? The answer is the best car is the Sawi car and it costs 1 million. Great. Now let's move that embedding. The steps are very easy. Just I want you to do this by your own. You're going to just create here a file inside ingestion, create a file called embedding.py, and inside it just move that code and do the imports. Now pause the video and try it with your own. Now I'm back. Let me show you how to do it. Just cut this code and remove those comments and import this, the OpenAI embeddings from here. And also import OS. And also don't forget to load the environment. So from .env, just import load.env and just call it load.env and press save. Now let's take those embedding and import them inside main.py. So here in main.py, just from src dot ingestion dot embedding, just import embeddings from this file here. Okay, and now let's try our app again. So let's run our app to check that everything is working. Now enter the question. What is the price of Sawi car? The Sawi car costs 1 million. So that's the answer. So everything's working. Now let's go to this step. Can you move this to new file? This file, the name is going to be vector store.py. I want you to do it with your own. Just move this code here and then import it here. Now pause the video and try to do it with your own. Now let me show you how to do it. Just cut the code and go here and paste it. Let's remove this comment. We need to import the chroma, chunks, and embeddings. So the chroma, we can import it from here, LangChain chroma, and the chunks and embeddings, you can also copy them from here. You can also get them from here and press save. And use this vector store in main. So from src dot ingestion dot vector store import vector store. Now let's press save and let's try to run our app. I run my app each time I do a change to check that everything is working correctly without any issues. So now what's the question? Let's ask any question. Let's go to the data and ask about this car here, Caro Volt S. What is Caro Volt? That's the question. The answer is Caro Volt is CCC electric vehicle. And so everything is working. Now we are done with the first pipeline. Look, the first pipeline was 4 steps and we moved them into separate codes here. we moved the embedding here in this file and ingestion in this file and splitter here. Let's remove this comment and the vector store here. Now I have a task for you. I want you to implement this task with yourself, and I'm going to give you the solution next lesson. See this first pipeline, the user question pipeline. I have moved them into files. I want you to do that with this second pipeline. I want to create a couple of folders and files and move that code inside it. Okay? Do this task and see you in next lesson. Now it's time to also move that code into files. So let's close all those files and let's start with the first three steps. Define the question and create the embedding. So inside the retrieval here, retriever folder, I want to name it retrieval. Inside it, I'm going to create a new file and name it retriever. Retriever.py. And I'm going to cut all those codes here. Cut them and paste them here. Let's remove the comments. All those comments, I'm going to remove them. We got here the question and vector store, and we can import the vector store from this import here. So let's cut this line also and paste it here. Now let's import this retrieved docs here inside main because we need it here. If you try to run your app without importing them, you're going to find an error. Look, uv run main.py. See? Oops, I forgot to save. Just saving and close and clear. Now let's rerun the app. Look, we got here an error. The retrieved docs is not defined because we used it here, but we didn't import it. So you have to import them. So from src dot retrieval dot retriever, just import retrieve docs like that. Now let's try to run our app again, and in this time it's going to work. So enter the question. Let's say, what is CCC? We got also another issue, the question. We didn't import the question here, and we use it here in the formatted prompt. So we need to import it here also. So here, just add a comma and add the question. Now let's press save and try to run our app again to check that everything is working. Now enter a question. The question is, what is CCC? And press enter. Now CCC stands for Car Company, also known as 3Cs. Okay, everything is working. Now let's make the same with this create prompt. Let's remove this comment. I'm going to leave this context because we're going to send this context in API calling. So I'm going to leave it here. The context and the formatted prompts because we're going to send them to the LLM. Okay, so I'm going to leave them here until we reach the section of FastAPI. Okay, so let's move this prompt template. So inside the folders, inside prompt, let's create a new file. Let's name it main prompt.py. And inside it, I'm going to cut those lines here and paste them here. We need this import chat prompt template. So let's go and get it from here and paste it here like that. And don't forget to get this prompt template and put it inside main. So from src dot prompts dot main prompt, just import the prompt template because we will use it here, prompt template. Okay, now the final thing is the LLM. Inside the folders, inside the LLMs folder, I'm going to create two files, one for Grok and one for OpenAI. So grok.py and openai.py. For OpenAI, I'm going to cut this part here and go to OpenAI file. And we need here to import the OS and load the environment and also the chat OpenAI. So at the top here, let's cut this line here and paste it here. And let's import OS. And also don't forget to load the env. So from .env import load env, just add it here and call load env. Okay, and let's name this OpenAI LLM. Okay, now we can import it here. So from src.llms.openai, just import OpenAI LLM. Okay, and the same with Grok. Let's copy this part of code here and go to Grok here and paste it. Let's remove those comments and uncomment this. And let's add the imports that related for loading the environment variables and also import chat Grok from here, from LangChain Grok, just import chat Grok. So let's copy that and paste it here. Now we are in the main.py. We can remove that and remove that line also. And in response, we can use OpenAI LLM, or we can also use Grok LLM, but we need to import it. So from src.llms.grok, just import, let's give it a name here. Let's name it Grok LLM. Okay, so let's import Grok LLM like that. Now let's test. Let's add anything here inside the data. For example, inside the jobs. Let's add here inside the jobs. Let's go down here. Let's add a job here. AI engineer is required and should have 7 years of experience in RAG. Okay. Now let's ask a question. So let's run the app. So uv run main.py and ask a question. Is CCC hiring an AI engineer? Now the answer is yes, CC is hiring an AI engineer and the role requires 7 years of experience in RAG. Let's try to add your salary with salary. For example, let's make it $10,000. And let's try the other LLM, the Grok LLM, like that. You have to remember that if you open this Grok file, we use here Quen, okay? Later we're going to add some fixes here to get rid of those hard-coded values, okay? Now let's press save and let's try to test this Quen model. So let's ask a question. So uv run main.py to run our app, and the question is, what is the salary of AI engineer in CCC? Now he is thinking, all of that is thinking, okay, let's tackle a question. All of that are thinking. And the final answer is 10,000 as stated in the context. And it was a correct answer. Look here, AI engineer is required and with $10,000. Now, if you have a look at this file here, no need to this import. Look, it looks beautiful. It looks more structured and cleaner than before. And we have put the other code inside another files. And it's a very good approach for real products and real projects. Now, if you have a look at our code, it's now cleaner than before, but we want to make it more cleaner. Let me show you something. If you open the Grok LLM, look here, we here load the env, and also we load the env in OpenAI and in the embedding also. So if you search here with load.env, we got here 3 times. And code duplication is a very bad thing. So I want to load only the env only 1 time, not 3 times. And also those hard-coded values like GPT-5.5 and Quen and this model name also, it's not a good idea to leave them as hard-coded like that. And it's better to add them in a configuration file. So here inside the files, inside core, I'm going to create a new file and name it config.py. And inside it, I'm going to create a class. Let's name it class config and put here some values. First, the key names. Let's close other files and open.env. Let's get those key names and OpenAI key and Google API key, like that. And this key is going to be equal os.getEnv. So to use getEnv, we need to import os and also from .env import load.env and load.env, like that. Okay, now for Grok API key, I'm going to make it os.getEnv and this value, Grok API key. And the same for OpenAI key, so os.getEnv and put inside it the OpenAI key. And finally, the Google API key also is going to be os.getEnv, and inside it, we're going to just pass here the Google API key. Now, let's create an instance for this class. So down here, let's create a config instance, and this is going to be config class. And let's use this config in our app. So let's search again for loadenv here. We got here in the embedding. So instead of all those things, I'm going to just from src.core.config, just import config. And instead of this, I'm going to just add here config.openAI key, because we are using here the text embedding from OpenAI. Okay, now the same here in Grok. So let's get rid of this and this two also, and just from src.core.config, just import config, and down here it will be just config.grok API key. And finally, in OpenAI here also, I'm going to just remove all of that code, and from src.core.config, just import config, and here is going to be config.openAI key, like that. And let's remove this unnecessary import and press save. Now let's try to test to see our code. Is it work good or not? So uv run main.py to run our app. Now enter a question. The question is going to be CCC stands for what? Now we got answer here. CCC stands for Caro Car Company. And here inside the config, you can replace the values here and load the environment variables only one. Now our code is more cleaner than before. but we can make it better than that. We want to get rid of all hard-coded values. What are hard-coded values? Let me show you. Look, this value here, it's a hard-coded value. And here also in OpenAI, this model name, we want to place those model names and other hard-coded values like the overlap of the chunk size, the Chroma database directory. We want to put them inside this config file. So let's start with those three files. First here, this hard-coded value, I'm going to copy it and go back here in the config. And let's add a variable here. Let's name it embedding model. And he's going to be this string here, text embedding 3 small. Okay. And go back here in the embedding and just use config dot embedding model like that instead of this hard-coded value. Okay, now we're done with the embedding. Let's go to Grok. See this name here. Let's name it Grok model. Let's make it down Grok here. So Grok model name, and he's going to be this value like that. Let's add a space here. And in Grok, we're going to just use config dot Grok model name like that. And also in OpenAI, I'm going to just cut this and let's go down here and just add a variable name here. Let's name it OpenAI model, and he's going to be this value, GPT-5. Okay. And there I'm going to just add here config dot OpenAI model like that. Now we still some hard-coded values. For example, that size chunk. So if you go to splitter file, this file here, we got here chunk size and chunk overlap. Let's store those numbers inside here the config. So let's add here chunk size, and it's going to be 1000, and chunk overlap, and it's going to be 200. And here in the splitters, we're going to just import the config. So from src.core.config, just import the config, and here instead of 1000, we're going to use the config dot chunk size, and here config dot chunk overlap like that. Now I have a task for you. I want to complete this class. What's still needed to do? I want you to search in this code base for any hard-coded values and add them inside this config and use them inside the files. Okay, now pause the video and try to do it with your own. And start with the Chroma directory. So if you go to this file, the vector store, where is vector store? Vector store, I think it's in ingestion. Look, this is a hard-coded value. Go and store it in the config. Start with it and browse all the code in the project and do it. Now take your time, and after you're done, come and see my solution. Now, what I have done here, the data direct, I just add it here inside this ingestion in directory loader. When we load the document, I add here the config.dataDirect and data globe inside this globe. And also I have added the chunk size and chunk overlap, and added here also the Chroma persist directory, this directory here inside this file, the vector store file. So instead of put it here hard-coded, I just add it here in the config. And also the retrieval, I just added the search type similarity here instead of putting hard-coded, and also the number of retrieved chunks, I just added here also from the config instead of putting it as a hard-coded. So we got all the configurations in one single file, so you can change things easily, and those changes will affect all the code base, and you got only one place to change your configuration. That's make your code is cleaner and well structured. But now, before I close this video, let's try to test our RAG app. So uv run main.py, and let's ask him a question. What is Sawi car? I don't know, the provided context doesn't contain information. Sawi car, user state that's the best car, Sawi car, and its cost. No details about this vehicle are included in the official inventory listing. Now, this is not the best answer that we want to get. We're going to make our RAG app get better answers in the evaluation section. Now, what we want to focus in clean code right now, and focusing on the best answers, we're going to make it later inside this course. Hello everyone and welcome to this section. Our RAG application is working, but currently it can only be used from Python code. In this section, we will build a FastAPI backend so our application can be accessed through a REST API. This will make it easy to connect a front-end mobile app or any external service. So we're going to cover what's FastAPI, the Postman and how to get and post requests using Postman, how to create the router, how to post a request and send a question to the LLM, how to push the code to GitHub, and deploy your app to render to make it global. And finally, we're going to cover Gradio and create a website that answers questions using Gradio. By the end of this section, you will build a FastAPI backend that exposes your RAG application through a REST API. So far, we have learned about large language models, embeddings, vector databases, and retrieval-augmented generation, and how retrieval-augmented generation works. Now it's time to expose all of that through a real API. By the end of this section, you'll have production-ready backend that can receive user questions and retrieve relevant documents and send context to the LLM and return AI-generated response. So we got here a question. Why do we need a backend? Let's imagine we have a mobile application or website. The user type a question like, what is RAG? If the front end, I mean the developer who is responsible for designing this website, the front end of this website or the mobile app, if he directly called the LLM, he will expose the API key to the client. And also, the retrieval logic will need to run in the browser and it will make it difficult to manage and scale. So, instead, the front end should communicate with our back end. The back end will handle everything related to AI and business logic. So, what's FastAPI? FastAPI is a modern web framework for building APIs with Python. It was created by Sebastian Ramirez and has become one of the most popular frameworks in the Python ecosystem, especially for AI and machine learning applications. One of the reasons FastAPI has become the standard choice for AI applications, it's designed to be both fast and developer friendly. Why FastAPI so popular? It's so popular because it has high performance, it's one of the fastest Python web frameworks available, and it has automatic validation. Whenever a client sends data to our API, FastAPI validates it automatically instead of manually checking every field. We simply defined a Python model and FastAPI takes care of the rest. And this helps reduce bugs and makes our code much cleaner. FastAPI also has automatic API documentations, and it's one of my favorite features in that FastAPI. It generates interactive documentations automatically. And also, FastAPI works beautifully with modern Python features like type hints, bidentic models, dependency injection, async programming. Now we got another question. Why FastAPI for AI applications? Almost every modern AI application needs an API. For example, ChatGPT like assistants, RAG systems, AI agents, recommendation engines, etc. All of those systems require a backend that can receive requests, communicate with all models, and return responses. So FastAPI is perfect for this job because it integrates naturally with Python, where most AI libraries already live. Libraries like LangChain, OpenAI, Hugging Face Transformers, ChromaDB all work seamlessly with FastAPI. Now, let me explain to you the process. It's a very simple process. So, the first step is the request. The request refers to the user question. This HTTP request will send it to the server. This server handles the logic. This logic, like retrieve the documents and answer the question. And finally, the response is going to be the answer, and we will return it to the client. For example, we got a mobile application or web application or front-end web application. We send the HTTP request to our FastAPI server, and it handle the request and execute the business logic and access the database and LLM and return the response. And we take this response. This response refer to the answer of the question. We return it to the client. In this lesson, you're going to learn how to download and use Postman. So in Google, just search for Postman and select this first option, or you can directly go here to download Postman. Since I'm using Mac, I got here Apple Mac Silicon because I'm using Mac. If you are using Windows, you should see something like Windows or something. Okay, now press here to download it. And after you download it and install it, you're going to see interface like this. To create a request, just press on this plus icon here to create new request. And here you will put the URL of this request and press send. When you press send to any request, you're going to get the response. Let me show you. For example, let's search for dummy API for testing. And let's open this website, dummy.json. And scroll down. Let's try to get this URL. Just get this URL like this. The URL is dummyjson.com/products and press send. Now, when you press send, you send a request to this URL and you get this data. Look, products. All of those products are dummy products. Those are not real products. It's just for testing. I'm just show you that to let you know how Postman works. This is a GET request. This GET request to get data from internet, from URL without sending anything. But if you want to send a question like our RAG, you're going to make this post and press here on body and type your body here. The body is going to be a question. We're going to type here the question. Let me show you. Let's search for any post request. Look, we got here add new post. In this lesson, you should only watch this lesson. Don't try those things. We're not going to use those things. It's just dummy data. I just want to let you know how to use Postman. It's a post request. You're going to take this post request and put it here. And you need to add here a body. Here's the body, title, and user ID. So let's just copy this body like that. Make it JSON. So you need to add here double quotes, and here also double quotes, and double quotes, and remove this. Now let's press send. And we got here the response. In our RAG app, we're going to send a question and we're going to return an answer. Now let's install FastAPI and create our first API. So let's comment all of that code. And down here, let's open the terminal and just type uv add FastAPI and UV-corn and press enter. Now we have installed two packages, FastAPI and UV-corn. Okay, and let's import our FastAPI. So from FastAPI import FastAPI, and let's create a FastAPI app. So app is going to be FastAPI, like that. Now let's create an endpoint that return hello, just a message that tells us hello. So at app.get, add here the route name and define the function. Let's name it hello API, and inside it we're going to just return a message that says hello FastAPI, like that. Now let's press save and let's run our app. To run our app, we're going to just use UV-corn. So just write UV run UV-corn main column app -- reload. This reload to reload the server automatically without closing and rerun the app again. So let's press enter. And now our UV-corn is running on this port. So let's copy it and go to Google Chrome and just paste this URL. Look, we got here the message, hello FastAPI. Let's try to change it. For example, let's go back to the code and just type hello FastAPI to the world, like that. Now if you go and refresh the page, you are going to see the changes here. Hello FastAPI to the world. You can also add a route name here. For example, let's make this a message, like that, and press save. Now, before adding anything, that was the root, like this. This is the root. But when you add anything here, you add a route name here. So if you refresh the page, you're going to see nothing, not found. But when you add the route name, this message here, you're going to see our message, hello FastAPI to the world. Okay? Now, that was our GET request. We're going to use FastAPI to create our POST request to send our question with the context to the LLM to get an answer. So next lesson, you're going to learn how to create a POST request using FastAPI. In this lesson, you're going to learn how to create a POST request using FastAPI. So that was a GET request. To create a POST request, just use the app, but instead of .get, you're going to add .post. And add also here a route name. I'm going to name it ask. Okay? And down here, define the function. So def ask question. This function is going to take the request. This request refers to the request body, to what we're going to send to the server. Okay? So we're going to just return the question, and this is going to be request.question. This is the question that we're going to pass in the body. Okay? And answer is going to be, this is a temp answer. It's just a temp answer until we connect to the LLM to get a real answers. Okay, so any question that you're going to ask will return this answer here. But we want the user to send only question as a string. He can send a number, can send Boolean or any else data types. So we want to pass here a string. So let's define a schema for this POST request. This schema, it's like a form or a shape for the question. Our question must include a text field called this question. Okay, so here at the top here, let's add a class, name it question request, and add inside it the base model. We can import this base model from Pydantic. So from Pydantic, import base model, like that. This base model to define the shape of data people send to us. Okay, so this class, we're going to add here a main property called question, and this question is a string. Okay, now let's test our endpoint, our ask endpoint. So let's open Postman. There's our Postman. Let's press here to create a new request. It's going to be post request. We're going to post to this URL, HTTP, this localhost here. You can get it from the log, this here. This here, 8000, the port 8000, and just add /ask. This ask should be this route name here. So if you change this ask, you should change it here also. Now let's go in the body. Let's try to send a request without a body. Look, we got here an error, missing query request. So we need to add in the body request. So let's add here in the body a key called question, and this question is going to be let's just type what's the website and press send. Oops, we still got here an error. Oh, I know. Let's go back to the code and add this question request here. So let's add this here like that. Now let's go back and try again. Now let's press send. Look, we got here the question, what is the website? And this is the answer. If you try to type anything or any question, for example, how old are you? He will return this answer. This is a temp answer because we return it as a hard-coded because we didn't connect our ask endpoint to the LLM yet. But when we connect this endpoint to our LLM, he will answer good answers. Okay? Now, if we continue creating the API's logic in the main.py, we're going to ruin our code base again. So it's better to add those APIs into a separate files and separate folders. But how to do that? Let's go to the files here and go to this API file and create two files. The first file is chat schema.py, and inside it we're going to add the schemas for our endpoint, and also add another file and name it chat router.py. This is for our router. We're going to put here our endpoints. So in the schema, let's define our classes here. So let's go back to the main and copy this class here and go to chat schema and paste it here. And don't forget to import the base model. So let's go up here and import this base model and paste it here like that. Let's name it chat request. Chat request like that. Okay. And let's also add another for chat response. So let's copy this and paste it here and just change this to make it response like that. Okay. And this response is going to be an answer, not a question. So the request is going to be question, the response is going to be the answer. Okay. Now let's go to the chat router and create our endpoint. So let's move those two, cut them, and paste them here. But instead of using app.get, we're going to use router. So from FastAPI, just import API router like that. And let's define the router. So router is going to be API router like that. And instead of using this app, we're going to just use router. So replace this app with router and here router. And import the two schemas here. So we got here chat request and chat response. So let's import them. So from chat schemas, just import chat request and chat response. And get this chat request and put it here. Like that. Now, to use those two endpoints in our main file, you just need to go here in the main file and just import the router. So from src.api.chatRouter, just import router. Okay, and after the app here, we're going to just app.include router like that, and just pass here the router, this router here. Now we have moved our APIs to this file, chat router file. Let's try to test it. So let's open Postman and let's try the same request here, post request with question ask. Now let's press enter. I think we got a problem. Look, we got here a problem. No module named chat schema. So what is this issue? Chat schema, chat request, chat response. Let's go chat router from. Yeah. This import should be from src.api.chat schema like this. So from src API chat schema and press save. Now let's save and try the request again. So let's press send. Now look, everything is worked correctly. Let's try to test this endpoint, this get message. So here, just instead of ask, just add message and make this get and press enter. Now look, we got here the message. Hello, FastAPI to the world. This message here. Let's try to test our validation. So if you see here in the chat schema, we should take a question as a string and return answer as a string also. So let's try to send anything is not string. So let's go back to the ask and make this post. And let's try to send, for example, 222 like this. This is a number. Look, we got here an error because we defined it here as a string. If you make this integer, now he's going to work. But we made it string, so he will return an error. So you have to give it a text string here to make this endpoint works. Now let's make some cleanup. So in the chat router here, we don't need this endpoint. It was just for testing. So let's delete it and just leave the ask, this ask endpoint. And see you in next lesson. Now it's time to get a good answers from our LLM using FastAPI. So remember the main.py, remember that code that we have commented. Let's copy all of it like this and get it here inside the chat router and uncomment it like that. So we need to make those imports, and here's the context, here's the formatted prompt, here's the response. Let's remove this print statement here and let's take those three things, the context, the formatted prompt, and the response, let's cut them and put them here inside this function, ask question function, like that. Oops, let's just add space here and add space here. So those three things, just put them inside this function, ask a question. Okay, and inside this return, just instead of this dummy data, just return the chat response, and inside it add the answer. Remember this chat response class. To make validation, we're going to just return it, and the answer is going to be response, this response from LLM, whatever it's Grok or OpenAI, response dot content like that inside this question in formatted prompt instead of importing it. So let's remove this question import, and down here the question that we will provide to the context, we're going to get it from our body, from the request. So what we send here, what we type here, this question, we're going to send it to the LLM. Instead, what we have typed in the terminal, instead of this input, remember this input here, we're not gonna use it anymore. So let's remove it because we're going to use our question from the body here, from the body that the user will send. Okay. And also let's copy this last line, retrieved docs, and put it inside here before the context, like that. And this question is going to be also request.question, like that. And don't forget to import the retriever. So from src retriever, just import retriever like that and press save. Now let's try to ask a question to our Grok LLM. So here's our postman. Let's send this question. How old are you? And press send. We got this answer. Here's the thinking. And the answer, I don't know. Let's try to use GPT. So at the top here, open AI LLM, just replace it with Grok and press send again. Now look, how old are you? He says, I don't know. Let's just try to send him this question. What is the website? And press send. We got here the website of the company, car example. Let's double check it. Okay, it's okay. Here's the website of the company. Let's ask him what's the email of the company. So what's the email of company? And percent. We got here, I don't know, the general company email listed in the context are drive career caro example, privacy career caro, and those a couple of emails. Let's ask him about the phone. So what's the phone number of CCC, the CCC company, and press send to see the answer. CCC phone number is 1-800-CC Auto. 1-800-222. Let's double check. Great, this is the number, that's the phone number. But now we still run this server on our local host. Anyone will open this link, it's not gonna work. It's work on my machine. This link is local. So if you open the web here and try to go to this link, it's going to work on your machine only. But if you send it to anyone, he's not gonna work. Or even if you close the server here, so Control and C to close the server, this link is not gonna work because it's local. We need to make it global that anyone can use it. Your friend, he is developing a mobile app using Flutter or React Native. Your other friend, he is working on a website and need a RAG app. Send it to the back-end team, the front-end team. So we want to make our API is global. And that's what we're going to learn in next lessons. Now you can test your APIs local in your local machine. But we want to make our API global that anyone can use it. So anyone can use it. However, your teammate that is responsible for building the mobile app of the company and needs those APIs to create a chatbot app to this company, or the front-end team who is building a website and wants your APIs to create the chatbot for the company or anyone else. So let's make our APIs global that anyone can use it. So let's deploy them to render. But first, to deploy them to render, it's better to push the code into GitHub first. So open GitHub in Google. If you don't have an account, sign up and create a new account. And let's continue with email to register a new account. Now we are in GitHub. Let's go to the dashboard and let's create a new repository. Let's name it chatbot, like that. And let's press here create repository. Now let's push our code to this repository. First, we're going to add this command get init to initialize the repository. So get init. Now we have initialized the repository. Second, let's add all the files. But first, make sure that you in gitignore put this .env because you shouldn't push this .env file into GitHub for security reasons. Okay, so let's in the terminal just type get add dot to add all the files. After this, let's commit. So let's copy this command get commit -m first commit. You have to make sure that you installed the get system on your machine. If you didn't install the get system in your machine, this code is not gonna work. So make sure first you installed the get system, okay? And let's also add this command and press enter and add the remote. So let's copy this command and press enter. And finally, this command get push -u origin main. Now press allow because GitHub wants us to sign in. Now press continue and press authorized Visual Studio Code. You may not see this because it's a new account I have just created for just testing. But in your case, if you have already GitHub and Git system, if you have already logged in GitHub, you will not see that. I mean the process of authorizing the Visual Studio Code. And now we're done. If you get back to GitHub and just press reload, now you can get the repository here. Here are our repository files without .env. Never push .env here. Now, after pushing the code to GitHub, it's time to create and manage our server infrastructure. So here, let's just type render. We're going to use the render. Only just type render like that. And open this page, render.com, and press sign in. We're going to sign in using GitHub. This GitHub here. And press here authorize. And press here create account. Okay, we're going to get the mail verification. Let me just get the email. You're going to find an email like that. Just press here, verify your email. Now we are in render dashboard. Okay. We can skip this survey and press here web services and press on new web service. We are using GitHub, so press here on GitHub to connect our GitHub. So press here and select all repositories. You can also specify to specific repositories, but I will give render all the repositories and press install. Now select this repository and here's the name. Let's name it chatbot. The language, select Python 3. The region, make it as it is. The root directory is src. The build command is uvsync. This is also right. But the start command, we need to add here the start command when we want to start our app. So in start our app, we're going to add our command uvcorn main app. So this command here, uvcorn main app dash dash host 0.0.0.0. This host 0.0 to accept the external traffic, and this $port is the port render assigns. Okay, and now let's select this free. This free because you are learning on this project. If you want to build something professional, it's better to select this starter. But since we are just learning, let's select free. It will work, but sometimes the server will sleep and he will take some time to get ready and work. Okay, but it will work. But sometimes you need to wait for some time. Okay, now we got here the environment variable. So you can add it one by one, or you can press here add from.env and go to your code and open .env and just copy all those values and press them here. And press here add variables. Now press here deploy web service. We got here a variable required, just press here to delete it. And press here deploy web service. He will ask you to add your card, but don't worry, we have selected the free plan. So let's real quick add our card details. Now after press deploy, we are now building our app. Now we are live. Congratulations, chatbot is live. Now if you press here view, you're going to find this link. But before I test it with you, I would like to mention something. When you fill your payment info to render, he may take $1 from you and return this dollar for you. In just 1 minute, he will just take $1 and return this dollar for you. It's just for testing your payment or something, okay? I just wanted to tell you that because you should know that, okay? Now, let's go to this website and copy it, and let's go to our postman. If you press send here and ask a question on your local host, he's not gonna work because you didn't start your local host server. But if you replace this with the link from render, this link here, this is the link of our deployed RAG app, and press send. Great, we got here an answer. The phone number for CCC Car Company is this number. Let's ask him another question. What is the best car in the company? Ampersand. Not found. Let's try again. Send again. The best car in the company is the Sawi car, and it costs $1 million. Now, great. Now you got here a link that anyone in the world can use it and can use your service, can use your API to use your RAG app, your RAG chatbot app. Now let's do some refactor. If you open the files here and go to API, chat router, you're going to find here that the logic that's responsible to get the answer inside this router here, ask. We want to make our code reusable and we don't want to duplicate code. So it's better to move that logic into a function, to use this function here inside the route and inside Gradio, and to use it anywhere else. So let's create a function to answer the question. So let's create a new folder inside src. Let's create a new folder and name it chat. And inside this chat folder, I'm going to create a new file and name it rag.py. Inside this file, I'm going to move this ask question logic. So first, let's cut that code, those three parts here, and create here a function. Let's name it ask question, and it take a question, the type of its string, and return string. Inside this function, I'm going to paste the code that I have just copied. Retrieve the docs, the context, the prompt, and the response. And finally, just return the response.content, like that. Now we need those imports. So let's go back to chat router and cut those imports, the retrieval, prompt template, OpenAI, and Grok. So let's cut them and paste them here, like that. And instead of this request.question, I'm going to pass here this question parameter. So let's paste it here and also add it here, like that. Now let's press save and let's go to chat router and use our function. So let's delete a couple of lines here, empty lines, and down here, let's change the name of this function. Let's just make it ask, and it take a request, and the answer is going to be our function ask question function. So let's import it. So at the top here, from src dot chat dot rag, just import our function, the ask question function. So the answer is going to be ask a question function, and inside it we're going to pass request dot question, and we're going to take this answer and just pass it here, like that. Now let's press save and let's test our code. So let's open the terminal and run our app. uv run uvcorn main app dash dash reload, and press enter. Now let's test our code. So we got here the question, here's the port 8000. Yes, let's ask here a question, this question, what is the best car in the company, and press send. And great, the best car is Howie car. So everything is working. And we got here the ask question logic inside a separate function. So it allows us to use it anywhere and in multiple places without duplicate the code. Now let's create our website, our demo website. So let's use Gradio. So open the terminal and run this command. uv add Gradio to install Gradio library. Now, after installation is done, let's go and create a new file. So let's close this and go to folders, and inside src, let's create a new folder and name it UI. Remember, you are not responsible for creating the UI. As an UI engineer or a RAG engineer, you're not responsible for building the UI. It's the front end responsibility. But we're going to just create a demo using this Gradio. Gradio will build the UI for us quickly and fast. So in the UI, let's add this file, Gradio app.py. At the top here, import Gradio as gr to use Gradio. And remember the function that we have created, the ask a question function, let's import it. So from src.chat.rag, let's import ask question function. Then let's create a function to return the response for us. Then let's create a function to pass to Gradio chat interface. Let's name it respond. So const respond is a function that take the message as a string and the history as a list. And this function should return string. And inside this function, we're going to return our function, our ask question with a message. We're not going to pass history right now because our chatbot is stateless until now. it got no history. We're going to handle this history later, but I just added it here because this history parameter is required by the chat interface callback signature. Okay, now let's create our demo. So demo is going to be gr.chat interface, and inside our chat interface I'm going to pass a couple of things. The first thing is the function, and this function is going to be respond. The second is the title, and this title I'm going to name it rag. You can type anything, it's the title of your website application. I'm going to name it rag chatbot ccc 3c. You're going to see that inside the website. Let me show you. Like this image here, you're going to find it here in this title. And also I'm going to add description and some question samples. So in description, I'm going to add here a description, and I'm going to add in description here, ask a question about CCC. And finally, I'm going to add examples. So examples, it's a list. I'm going to add here a couple of questions. The first question is, what is the best car? The second is going to be, what is 3C? And finally, what is your privacy policy? And now we're done with our Gradio app. Let's go to main.py and use it. So go here to main.py, the root of our project. And first, let's import Gradio as gr, and also let's import the demo. So from src.ui.gradio app import demo. And down here, don't remove this code to let that our API is still working and API is still available for post a question. And let's just down it. Let's mount Gradio app to return a new app wrapping the original app. So let's add your app. It's going to be Gradio.mount Gradio app, and pass here the app and demo and path. Path is going to be slash. This line of code here, we use it to embed the Gradio app inside our FastAPI application. This app refers to our FastAPI app, okay? This demo is our Gradio interface that we have created here. And this path to specify where the Gradio app will be available inside the FastAPI app, because it's like this, he's going to be inside the root. So we just add slash without anything to make it in the root. Now let's try to run our app. So open the terminal and just run uv core main app -- reload. Now our app is run successfully. Just open at this base URL. It's up here. It's our local host. Just click on it. You're going to find here this Gradio. And here's our chatbot app. Let's copy this and open it in Chrome. It's better. So here's Chrome. Let's paste it here and press enter. Now we got here our RAG chatbot. Here is the title. Here's the question. Here's in the setting, you can use dark or light mode, or even the language. You can choose any language. And here are the 3 questions. Remember those 3 questions inside the Gradio app. Look, what's the best car? What's 3C? What's your privacy policy? Those are the questions here. Let's, for example, ask what is 3Cs. Now we got here a question. 3C is shorthand for car company. Let's ask him another question. For example, what is the best car? And press enter to get a response. The best car is the Sawi car and it costs $1 million. Now, this is a local host. No one can use this. This a local host. What if you want to run Gradio on the internet so anyone can access it. You can send it for your friends to test it or anyone. For a demo, you can make it like this. You can go to main.py and make it as a demo. So here, just add demo.launch and inside it add the share property and specify it as true and press enter. Now let's close the server and start it again. And this time we're going to get a link, and this link is a global link. Anyone can use it and anyone can use your Gradio app. So here's the link. So let's copy it and paste it here. This link is live and anyone can use it, but it's just as a demo. Because when you close this terminal, this will not gonna work anymore, okay? So this link is going to be available till you run the command here. But the difference between it and the localhost, this localhost will work only on your machine, but this will work everywhere. Now let's ask here a question. Let's just say hello or hi. And the response is, hi, how can I help you with car company information?